Hi, my name is Marcus Fireman. I'm a PhD candidate at the Federal University of Rio Grande do Sul. And this research was developed with Saurin, a professor at the Federal University of Rio Grande do Sul. And today we will talk about the chain of waste and the moderating role of making do. Chain of waste has been used to describe the systemic impact of some types of waste. In this point, making do has been cited as a primary waste that triggers other wastes, creating a chain of waste in construction. The chain of wastes are non-linear, so small wastes can create large consequences. The literature about chain of waste is only conceptual, and the applicability and utility of its concepts have not been properly explored. In this aspect, the functional resonance analysis method, FRAN, could be used to model a chain of waste in construction, since it allows modeling interactions between managerial and production function in complex systems. The theory related to FRAN was developed by Nagel, and it is present in his book, the Functional Resonance Analysis Method. And this theory can be understood through this chart on the right. This chart represents the performance variability of the multiple functions over the time. Each blue wave represents the variability of a function, and the functional resonance suggests that the combined everyday variability of multiple functions can create an expected result, which is represented by the red wave. So the red wave can be understood as a desired outcome or can be understood as a waste. The aim of the study is to analyze, based on FRAN, the role of making do in a chain of waste. And this investigation is relevant for two reasons. The assumption of making do as a primary waste lacks empirical grounding, and the notion of primary waste is elusive, as usually there is no single root cause for phenomena in complex socio-technical systems. So it is possible that making do itself is underlined by other types of wastes. There are five steps to FRAN application. The first is defining the purpose of FRAN analysis. In this point, we can analyze a retrospective view or a risk assessment. The second is to describing the function of the system according to 6 aspects. On the right, there is an example of FRAN model. And as we can see, there are 3 functions represented by hexagons. And on the board of the hexagons, there are 6 ladders. Each ladder represents an aspect. So there is the input, time, control, output, resource, and precondition. And it's important to say that a function can be connected to other function by some of these aspects, as we can see in this example. The next step is to describing the variability of the output of each function in terms of time and precision. And in this example, we can see that the function A and function B, there are inside the hexagon, there is inside on the hexagons waves a wave, and this wave is the variability of the output. The next step is to modeling how variability can propagate across the system, be either amplified or dampened. And in this point, we can see that the variability propagate across the system between the function A and function B, and it's not propagate to function C. And the last step is to devise practical solutions for improving the work system design. So about the research method. The research method is based on the development of a case study on an airport terminal with almost 30,000 square meters. And the company studied was company X, which is responsible for design, manufacture, and assemble metallic structure. And about the research strategy, it was developed in 3 main phases. The first phase is the chain of waste selection. The second is the front modeling. And the last is the analysis and discussion. And it is important to highlight that an interview based on the critical decision method, the CDM, was carried out with the site engineer, and this interview and the document analysis was used during all phases. So the first phase, they select the chain of waste. The chain of waste carry out in the process of gutter installation. And in this slide, we represent with a simple model the way work was imagined to be done. First, the company X designed the gutter and its components, and then manufacture and transport to the site. On the site, the workers need to install the support, which is highlighted on this picture. And after this task, the workers must install the gutter on the support. But in fact, the way work was done was totally different. And during the manufacturing, a failure happened on the make-ready process. By this problem, the components of the support were not available on site when the workers needed. To finish on the contractual deadline, the company X did an improvisation, and the metallic brace used normally to package the coil of the roof was improvised as a support, as we can see on the picture on the right. So about the front model. The front model shows us 4 important points. The first is that, as we can see, there are 18 functions in the system, and the different colors on the board of the hexagons represent different types of function, demonstrating the complexity involved in this system. The second important point is that the variability starts on the beginning of the system, on the function 1, and propagating across 11 functions. This propagation is represented by the orange lines which connect these functions. And the next important point is that the client identified a risk of delay and sent a contract notification to the company X, informing the possibility of executing the contractual fine. And this contract notification triggers the making do, because with just 1 week to the deadline, the last alternative was improvisation. And the last important point is that making do happened on the function 7, but as we can see, there are other ways upstream this function, which suggests that making do is not a primary waste in this system, in this chain of waste. So we identified that making do involves a trade-off, as we can see on this slide. The company X needed to decide between take the risk of a contractual fine or take the risk of related to making do. And with this trade-off, we can understand that the moderating role of making do in the chain of waste. The other conclusion is that Slack can be used as an approach to prevent making do. So if the make read process fail, the company X could use some Slack resource before making do. For example, the company X could use a double checking during the check of material, or the company X also could use an alternative supplier to the missing components. Or other option is that if the company X had experienced workers in its team, maybe the improvisation result on desired outcomes and not making the waste. So for future studies, we suggest that the cost and benefit analysis of providing Slack to construction project. The other suggestion is the use of Run for investigating making do in a broader set of cases with different level of complexity. And other option is the Run might be used as a risk assessment approach for the identification of variabilities that can give rise to wastes. So thank you so much. And here there are our contacts for some connections.